This is the Pearson EDEXCEL IAL Mathematics Pure Math 2, January 2023 paper. This video is going to be dealing with question 6, which has circles and their equations and tangents to the circle. The circle C has the following equation. Number A, I find the center of circle C. So we just need to convert this to center radius form. I use the completing the square method. So complete the square twice. 6ai. Okay. We have x squared. I rearrange it plus 8x plus something. It's going to be something there. Plus y squared minus 4y plus something. It's going to be equal to 0 minus, and then you have to add those same things on the right-hand side. So whatever you had over here is going to be also over here, because whatever you do to the left-hand side, you have to do to the right-hand side. And whatever was here is just going to be over here. And what are these things that I'm talking about? Well, if you remember, then it's in order to complete the square, we take the b over 2 squared. And for our first section here, b over 2 squared is 8 over 2 squared. 8 over 2 is 4. 4 squared. That's going to be 16. Okay, so first is plus 16. So we plus 16 on this side, we have to do plus 16 on this side. Keep it balanced. And then we look at the y's. Well, our b over 2 squared. To get that, we're completing the square by design. Our b is minus 4. Minus 4 over 2 squared. And then minus 4 over 2 is negative 2. So it'll be negative 2 squared, which is 4. Negative 2 times negative 2 is 4. So plus 4. Okay. So these are, we've designed ourselves perfect squares that we can use to find the center of the circle. So the next step, once you've designed your perfect square, is to contract them. There are 2 perfect squares. You've completed the square twice. So we contract x squared plus 8x plus 16. And it'll be, so you take the square root of the x squared term. Square root of the x squared term is x. X square root is x. And then we take the square root of the constant term. 16 square rooted is 4. And then you just bring down the sign of the middle term. Oopsie. That's not right. Okay, negative. Remember, this is squared. So that's the quick method to find the contracting the square. We do the same thing. So square root of y squared is y. Bring down the middle term. That was a plus 4. Bring down the sign of the middle term. And square root of 4 is 2. All right, there we go. And on the other side, we have 16 plus 4, which is 20. Here we have, this is perfect. This is center radius form. So this is center radius by completing the square. That's what we did. That is supposed to be an S. Okay. Good, but we still haven't answered the question. The question asked for, whoopsie. The question asked for this, the whoopsie was that's a plus. We bring down the sign, and I didn't bring down the sign. The question asked for the center of the circle. So once you're in center radius form, as the name suggests, it's center radius. So center radius means that x minus a squared plus y minus b squared equals r squared. That's our center radius form. And from this form, we know that our A and B is the center of the circle with opposite signs. Opposite signs, okay. So we have almost by inspection, we have already our answer. So we can do opposite signs. So -4 + 2 is the center of the circle. And I think that was all that was asked for in this question. A. II. Okay. II says, find the exact radius of the circle. Well, now we've got center radius form, then we know that r squared is in the position where we've got this 20. So we know for number II that r squared must be equal to 20. So r squared is the radius squared. So we know then if we square root both sides that our radius is actually the square root of 20. And you want to make sure it's in its simplest form, and that's going to be 2 square root 5. Perfect. Number B, some more information is given to us. It says that the point P lies on the circle. Given that the tangent at P has this equation. Okay, so to draw that, they're saying here's the circle that we're working with, and at point P, which could be anywhere on the circumference of the circle, there's a tangent, and this tangent has the equation of x plus 2y plus 10 is equal to 0. So this is our tangent line. Okay. So it's saying find the coordinates of P. Well, we can use simultaneous equations because P is on both functions. It's on the, well, not functions, it's on the circle equation and it's on the tangent equation. So let's set that up. Here's our circle. Here's our circle equation. And the tangent was x plus 2y plus 10 is all equal to 0. That's our tangent. Okay, we don't need this equal to 0 bit. This is the function. So when I do, the easiest is to get x on its own. If you get x on its own, it's much easier to sub that x value into the other equation. So far we can quickly label this one as equation 1, the circle. And let's rearrange equation 2 slightly. So x, why did I say ignore the 0? We still need the 0. We still need the 0. See, that doesn't make any sense. No. Okay. We minus 10 on both sides. It's negative 10. Minus 2y on both sides. They cancel out on the left and becomes negative 2y on the right-hand side. So we can call this our equation number 2. Okay. We've got 2 equations. We can sub number 2 into number 1. So how this would mean that every time we see an x, we instead write minus 10 minus 2y, which is just in this one position. We'll keep a bracket there just to show what it looks like. Plus 4 squared plus y. Okay, I can't get away with that. Y minus 2 squared equal to 20. A little bit of simplifying here. So minus 10 plus 4 is minus 6. So negative 2y minus 6 squared plus y minus 2. Let's bring the 20 over to the left-hand side by minusing 20 on both sides. Oh, that was squared. Okay. We're trying to solve for y first, and then we can solve for x because it asked for the coordinates of the point P. which is some sort of xy. That's what we're busy aiming for. That's point P. Okay, let's start. So expanding a square, minus 2y times minus 2y is 4y squared. Take the middle two terms times each other, times by 2. So minus 2y times minus 6 is positive 12y, times by 2 is positive 24y. Positive 24y. Minus 6 times minus 6 is plus 6. Then we do it again. So y times y is y squared. Minus 2 times y times 2 is, because that deals with the inner and outer terms. If we were just to quickly show what I'm doing, in case that wasn't clear, minus 2, and then there's another minus 2y. There's 2 of them. So minus 2 times y times 2. Okay. Minus 2 times y times 2 is minus 4y plus 4. 2 minus 2 minus 20. Okay. Any like terms? X squared terms? This was y squared. Self-checking. Y squared terms? Yes. Y terms? Yes. And constant terms? Yes. Yes. Let's add those up. So we have 4 plus 1 is 5. 5y squareds. 24 minus 4 is 20y's. And 6 plus 4 is 10. Minus 20 is negative. Six. Something's wrong with this. Whoops. That's not correct at all. What is 6 times 6? It's 36. Okay. So we have 36 plus 4 minus 20. Yeah, so that's just going to be 20 equal to 0. So we need to get the y options. So I'm going to divide all 3 terms by 5 just to make it a little bit easier. Obviously, 0 divided by 5 is just 0 on the right-hand side. So minus 4y plus 5. 20 divided by 5 is not 5, it's 4. So this contracts also into y minus 2, because you take the square root of the first term, the square root of the third term, and it's actually a square. So you can contract the square again. And we square root both sides. So square root both sides. Y minus 2 is equal to 0. This cancels out. Just be careful here. This would be positive or negative if you add your own square root. So this could be positive or negative. So positive y minus 2. Positive y minus 2 therefore equals to 0. Therefore y equals to 2. And then negative y plus 2. And therefore is equal to 0. Therefore y equals 2. So in this case, it didn't really matter. Okay, let's just to be thorough. When you add your own square root, always watch out. There might be a hidden value there somewhere. What do we have? So we have y equal to 2 as our value for y. Last step for simultaneous equations is you sub that back into one of your equations. So I'm going to sub it back into equation number 2. So let's just grab that from up there. Equation number 2. Okay. There it is. So we sub y equal to 2 into 2, which is down here. This wouldn't be actually a part of your proof, this part. So let's just move it away. So x equals 2 minus 10 minus 2. Every time you see a y, you change it to a 2. Minus 10, 2 times 2 is 4. So it'll be y equal to, oh, something's gone wrong. Let me go back and see what's gone wrong here. Oh, it went wrong a very long time ago. So I'm self-checking. And I'm trying to find an error. This minus 20 here should be a plus. So we had indeed plus 24 minus 4, which is plus 20. That's plus, and this is plus, and this is plus. Then this would be plus, and this would be negative. So that all our 2's are negative. Okay, self-checking. Good. So minus 10 plus 4 is negative 6. And I think that concludes the question. I think they asked for, so P therefore is our X is negative 6 and our Y is negative 2. And that's correct. All right. Number C, last question. Find the equation of the normal to C at point P and give your answer in the straight line form. Y equals mx plus c. Okay, so what do we know about the normal to the curve? Well, this is a tangent to the curve that we have drawn here. Oopsie. And the normal to the curve is just perpendicular to the tangent. So normal to the curve is a line perpendicular to the tangent to the curve at that point. Okay, so that's the normal. So we're getting the equation of the normal, number C. And what's the equation of the normal? What do we know about perpendicular lines? Well, perpendicular lines, m times m equals -1. m1 times m2 equals if the line 1 is perpendicular to line 2. So first we need the gradient of the tangent, and then we can work out the gradient of the normal. Gradient of the tangent, well, this tangent is given, but it's not given in standard form. So x plus 2y plus 10 equals to 0. We're going to put this in standard form. So minus x and minus 10 from both sides. It cancels out on the left. 2y, divide both sides, all three terms by 2. So this cancels out on the left, and y equals -1/2 x minus 10 over 2, which is 5. -1/2 x minus 5, which just shows that this picture is inaccurate. It's sort of more like this. Must be a negative gradient. Anyway, it doesn't matter. So still just the circle has been twisted. Okay. So this is a y equals mx plus c form, which is the correct form. And so now we have our m. our m of our tangent is -1/2. So we know that m times m must equal to -1, or to find the m of the normal, the quick method is to just flip this around and change the sign. Flip this around and change the sign. So that would be 2. But let's look at the actual. If you forget about this quick method, then we have the actual working. So m times the normal times by m of the tangent must be equal to -1. Therefore, we have the m of the tangent is -1/2 times by m of the normal must be equal to -1. If we want m of the normal, we divide both sides by -1/2. And we can tip in times, this side cancels out. So gradient of the normal is equal to -1 times by -2/1, which is just 2. Okay, so that's the long method in case you forget the short method. We've got the gradient of our normal equal to 2, and we need it in the form y equals mx plus c. So the last thing we need, if we sub in our 2 here, y equals 2x plus c, is to find some sort of xy that we can sub in there to solve for the unknown c. So let's go look. Okay, well, we have our point P. Our point P over there, which we got in a previous question, -6 minus 2. So sub in, oopsie daisies, that's not right. Sub in P -6 minus 2. So where the -2 x goes where the y goes, equals to 2 minus 6 goes where the x goes, plus c. -2 equals to -2 times 6 is -12, plus c. Add 12 on both sides, and we get 10. So c is equal to 10. Finally, just it asks for it in this form. So y equals to 2x plus 10 is the final answer. And I think that completes question number 6.